Researchers often summarize their data using a particular measure of central tendency, one score that represents the entire set of data points. The most straightforward measure is the mode, the most frequently occurring score, which is useful when computing totals for categorical data, such as professional occupation. Here, the mode is noted as writer, since they constitute the majority of what careers were reported. Another measure is the median, the true middle point in a set of numerical data that are arranged in order of magnitude. Here, the median of salaries is $65,000, with half of employees paid at or above, and the other half at or below this midpoint. In cases with an even number of values, the average of the two middle numbers determines the median. Finally, the most common measure for numerical data is the mean, the arithmetic average, which is equal to the sum of all numerical scores divided by the number of data points. For example, the total sum of all incomes would be divided by the number of people employed, in this instance yielding a mean of $140,000. Because this measure takes into account all values in the data set for calculation, researchers usually prefer to report the mean. In a normal distribution, the mode, mean, and median have approximately equivalent values and are positioned exactly in the center of the curve. However, in skewed distributions, when either very high or very low scores are more prevalent and weighted more heavily, these measurements are not equal. If the majority of the participants reported low incomes, the mean would rise due to a few extremely high income scores. Thus, the mean's sensitivity to extreme values could result in an artificially high or low representation of the data. In this case, the median or mode would serve as a more accurate measurement. In the end, the best measure of central tendency is one that considers the pattern of distribution in the data at hand.
My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need to get done in a list view. Next,
In this lesson, you will learn how to calculate the median of grouped data from a frequency distribution table. The table shows the scores of students in a statistics test. The first column lists class intervals, which represent score ranges. For example, the first class represents students who scored between 50 and 59. The second column lists the frequency, which tells us how many students scored in each interval. For instance, in the 50 to 59 interval, the frequency is 6. This means 6 students scored between 50 and 59. The median of grouped data is calculated using this formula. Here, L sub m is the lower boundary of the median class. N is the total frequency, which is the total number of students. Cf sub b is the cumulative frequency before the median class. F sub m is the frequency of the median class. H is the class width. The first step is to identify the median class. To do that, we start by calculating the cumulative frequencies. The cumulative frequency of a class is the sum of its frequency and all previous class frequencies. For the first class, it is just 6, since there are no classes before it. For the second class, it is 6 plus 10, which equals 16. For the third class, it is 16 plus 7, which equals 23. For the fourth class, it is 23 plus 12, which equals 35. For the last class, it is 35 plus 5, which equals 40. Note that the cumulative frequency of the last class is the sum of all the frequencies. It is the total frequency, which represents the number of students. So, n equals 40. Now we will find the median position. Remember, the median is the middle value. So to find its position, we divide n by 2. 40 divided by 2 gives us 20. This means the median is at the 20th position. Now we need to identify the class that contains the 20th value, which will be the median class. We will do this using the cumulative frequency. Note that a cumulative frequency of 6 means this class contains values in positions 1 through 6. A cumulative frequency of 16 means this class contains values in positions 7 through 16. A cumulative frequency of 23 means this class contains values in positions 17 through 23, and so on. Since the median is in the 20th position, it falls inside this range. Therefore, the median class is the 70 to 79 interval. This tells us that the median lies somewhere between 70 and 79. Keep this in mind. It's a good way to check your answer later. Now that we have identified the median class, the next step is to find its lower boundary. The lower boundary of the median class is the midpoint between the upper limit of the previous class and the lower limit of the median class. This means taking the average of 69 and 70. That is 69 plus 70 divided by 2, which gives us 69.5. Therefore, the lower boundary of the median class is 69.5. By the way, if there is no gap between classes, meaning the upper limit of the previous class equals the lower limit of the median class, you can simply use the lower limit of the median class as the boundary. Next, find the cumulative frequency just before the median class. This is the class right before the median class, and its cumulative frequency is 16. Next, find the frequency of the median class. The median class has a frequency of 7, right? Finally, find the class width. To do this, subtract the lower limit of one class from the lower limit of the next class. For instance, in this class, the lower limit is 80, and in the next class, the lower limit is 90. So the class width is 90 minus 80, which equals 10. Note that since all the classes have equal ranges, no matter which 2 consecutive classes you pick, the class width will always be the same. Now substitute the values you obtained into the formula. Then simplify. Go ahead and use a calculator if you would like. After simplifying, we get a median test score of 75.21. Notice that this makes sense. It is between 70 and 79, right inside the median class, just like we expected. Keep in mind that the median here is an estimate. This is because we don't know the exact scores of each student. We only know the ranges and how many students fall into each range. So, the median is not a specific score, but rather an estimated middle value. To recap, here's the formula to calculate the median of grouped data, along with what each variable means. Here's a quick summary of the steps you need to follow. And finally, here's a practice problem for you to try on your own. Pause the video, give it a try, and then check your solution. But wait! To learn how to find the mode of grouped data, click on the video on the screen. You can also find a practice problem for you to try on your own.
When you have the perfect response in your head, but your fingers just can't keep up. We've all been there. Typing, deleting, retyping.
In this lesson, we're going to talk about how to calculate the median of the group data shown below. So the first column, we have the grade intervals for students in a class. The second column represents the frequency of those intervals. The third column represents the cumulative frequency. So what this table tells us that 3 students scored between 40 and 49. 5 students scored between 50 and 59, and so forth. Now, the formula that we need to calculate the median is L. L represents the lower boundary of the median class, times n over 2. N is basically the sum of all the frequencies. It's the total frequency. So you could say n is basically the sum of all the frequencies. Minus c. C is the cumulative frequency of the preceding class with respect to the median class. F is the frequency of the median class. And H is the width or the size of that class, or the size of the intervals. So first, let's find L. Actually, before we find L, we need to determine the median class. So in which interval does the median occupy? Is the median between 50 and 59, 60 and 69, 70 and 70?
around 70 to 79.
89 or 80 and 89? What would you say? In order to find that answer, we need to find n first. So let's fill out the third column, the cumulative frequency column. So here we have 3. If we add 3 and 5, we get a total of 8. 6 and 8. If we add them, that's 14. 14 plus 9 is 23. 23 plus 8 is 31. 31 plus 7 is 38. So we can put 38 here. So that's the value of n. Now, if we take n over 2, we get 19. So around the 19th term is where the median should be located. So which interval contains the 19th term? So the first interval has the first 3 terms. The second interval has the 4th term all the way to the 8th term. The third interval has the 9th term all the way to the 14th term. The fourth interval has the 15th term to the 23rd term. So the 19th term is in this interval. So this right here is going to be the median class. The median is somewhere between 70 and 79. That's where the middle number is going to be. So now that we've identified the median class, we need to determine the lower boundary of that class. Now, if these two numbers were the same, L, the lower boundary of this median class highlighted in red, would just be 70. But because these numbers are different, they differ by 1, we need to find the midpoint, which is the same as the average of those two numbers. So the midpoint between 69 and 70 is going to be 69.5. That's the average of 69 and 70, or the midpoint, which will be the same in this case. We need to find the midpoint, which is the same as the average of those two numbers. But because these numbers are different, they differ by 1, we need to find them somewhere between 70 and 79. That's where the middle number is going to be. So now that we've identified the median class, we need to determine the lower boundary of that class. Now, if these two numbers were the same, L, the lower boundary of this median class highlighted in red, would just be 70. But because these numbers are different, they differ by 1, we need to find the midpoint, which is the same as the average of those two numbers. So the midpoint between 69 and 70 is going to be 69.5. That's the average of 69 and 70, or the midpoint, which will be the same in this case. So that's the lower boundary of the median class, 69.5. Now we know n is 38. C is the cumulative frequency of the preceding class. So the class that precedes the median class, below 70 is 69. So in blue, this is the preceding class. 80 to 89 is the succeeding class. That's the next one after that. So the cumulative frequency of the preceding class will be 14. So that's our C value. H is the size of the intervals. Now you want to be careful. Because these numbers are different, you don't want to do 79 minus 70 and say it's 9. The lower boundary of this class is 69.5. The upper boundary is going to be between 79 and 80, so it's going to be 79.5. H, which is the width of those two boundaries, is going to be 79.5 minus 69.5, which is 10. And it makes sense, there's 10 numbers in this interval. So that's our H value. H is 10. So it's not 79 minus 70, which will give you 9. The only way that's going to work is if these two numbers are the same. And if those two numbers are the same, then you could do that. It will lead you to the same answer. But when they're different, you need to see it this way. So now that we have the size of the interval, we just need to divide everything by f. F is the frequency of the median class, which we could see is 9. So now let's plug in everything. Actually, let's simplify it first. 38 over 2, that's going to be 19. Now, 19 minus 14, that's going to be 5. And this should be a 9 here. That's the frequency of the meeting class. So this is 69.5 plus 50 divided by 9. So this rounds to 75.05. Well, if we want the exact answer, it's 75.05 repeating. So that's the value of the median. And it makes sense. We can see that this number is in the meeting class. It's between 70 and 79. So that's how you can calculate
Oh, a lamp!
Stop it, I'm ticklish. You have released me, Aladdin. In return, I'll grant you 3 wishes.
I'd like to be as smart as a fox.
Hey Siri, switch off the television.
Okay, so finding the middle of a list of numbers sounds pretty easy, right? But what happens when you don't actually have the list? What if all you've got are these groups or bins of data? Well, today we are tackling that exact problem. How to find the precise center when all the juicy details are hidden away. Let's get into it.
So before we dive into the really messy stuff, we gotta build a solid foundation. Let's start with the basics, the simple case. Finding the median when every single number is laid out right there in front of us.
So what is the median, exactly? Well, think of it as the ultimate dividing line. Basically, you line up all your data from smallest to largest, and the median is that one number smack dab in the middle. It cuts the whole set perfectly in two.
And finding it is actually super straightforward. It's just a 3-step deal. Step 1, you gotta get your numbers in order. Literally, line them up from low to high. Step 2, count them up. How many numbers do you have? We just call that n. And step 3, if that n is an odd number, there's this little magic formula, n plus 1 divided by 2. That'll tell you the exact spot where your median is hiding.
All right, let's make this real with an example. So what we've got here are the heights of 11 football players. And hey, they're already sorted for us, which is nice. Our job is to find the median height of this team.
Okay, so we have 11 players, right? That means our n is 11. It's an odd number, so we bust out that formula. 11 plus 1 divided by 2 equals 6. Now, this is key. The median isn't the number 6, it's the height of the player who's in the 6th position.
So if we count our way down the list, 1, 2, 3, 4, 5, 6, boom! We land on 150 centimeters, that's our median. Simple, right? And that one number tells us a whole story. Exactly half the team is shorter than 150 centimeters, and the other half is taller.
Okay, but let's be real. In the real world, data is almost never that neat and tidy. And that's where things get really interesting. We run into what's called the grouped data problem. So what happens when we don't know the exact height of every single player? What if we only know how many players fall into certain height ranges, these bins? How in the world do you find the middle then?
Check this out. This is a perfect example. This table shows the weights of 40 students. But we don't have 40 separate numbers. Instead, we just know how many students fall into each range of weights. You see this kind of thing all the time with census data or
of big surveys. You get the summary, not the raw list of every single person. All those precise individual weights are hidden inside these groups. Now the cool thing is we can still figure out the middle spot. With 40 students, the middle is going to be right around the 20th student. And if we just add up the frequencies, we can see that that middle spot falls somewhere in the 145 to 153 pound group. But where? I mean, is it 146, 151? We can't just guess. We need a much more precise tool.
And that's where this special formula comes in. I know. When you first see it, it can look a little intimidating. But trust me, every single piece of it has a really simple logical job. We're going to break it down together, piece by piece.
Here it is. It looks like alphabet soup. I get it, but honestly, it's better to think of it like a recipe. L is our starting point. That fraction in the middle tells us how far to walk into the right group. And I tells us the size of our steps. Let's break down each ingredient.
Okay, first up, we have L. This is the lower boundary of our median class. So once we've figured out which group our median is in, L is our exact starting point. It's the starting line for that group.
Next up, N. And hey, this is the easy one. It's just the total number of things we're looking at. So for us, it's 40 students. Simple as that. We need N so we can find the halfway mark, which is just N divided by 2. All right, now for C. This stands for cumulative frequency. But here's the important part. It's for the class that comes right before our median class. This number tells us how many students we've already counted before we even get to the median's group. It's kind of like knowing how many people are already in line ahead of you. Okay, next we have F. This is the frequency of the median class itself. It tells us exactly how many students are packed inside our target group. You can think of it as the size of the crowd we have to navigate through to find our middle person. And last but not least, we have I. This is just the width of the class interval. Or, put more simply, how wide is that group? You know, what's the range? And that's it. That's our recipe. We have all the ingredients.
All right, theory's over. It's time to put this recipe to the test and find the exact median weight for those 40 students.
Okay, so here's our data again, but you'll notice we've added a couple of things, class boundaries and the cumulative frequency. And look closely at those boundaries. See how they're adjusted by 0.5? That's a super important step. It closes those little gaps between our groups, which makes the data continuous. So, first things first, we need that middle position, n divided by 2. Well, 40 divided by 2 is 20. So we are on the hunt for the 20th student. Now, if you look at that cumulative frequency column, you can see how we're adding up students as we go. We get to 17 students right before we hit this highlighted class. That tells us our 20th student has to be somewhere in this group, right? The one from 144.5 to 153.5. We found it. This is our median class.
Okay, now for the easy part. We just pull the numbers we need right from the table. Our lower boundary, L, is 144.5. The frequency of that class, F, is 12. The cumulative frequency before that class, C, is 17. And of course, we know our target spot, N over 2, is 20. And the width of the class, I, that's just 9. See? We've got everything we need.
So, let's plug all of that into our formula. We've got our median equals the starting point, 144.5, plus this whole chunk of calculation. That's 20 minus 17 divided by 12, and then that whole thing gets multiplied by 9. You can really see how each little piece of the recipe comes into play here.
All right, let's do the math. Okay, so 20 minus 17, that's 3. Divide that by 12, you get 0.25. Multiply that by 9, and you've got 2.25. Now for the final step, we add that to our starting point of 144.5, and we get 146.75. And just like that, we've pulled a super precise median out of that messy grouped data. Pretty cool, right?
So you might be thinking, okay, that's a lot of work. Why does this even matter? Well, it matters because in the real world, think about economics, public health, pretty much any science, data almost always comes to us in groups like this.
This formula, this tool, is so powerful because it lets us find the true center, the true middle of these massive complex datasets. So when you hear about things like median income or median house prices in the news, this is exactly the kind of math that's happening behind the scenes. It's how they get a really reliable middle number that isn't thrown off by a few super high or super low values. So the next time you see data that's all grouped up, you'll know exactly what it takes to find its heart. The only question left is, what stories is that data waiting to tell you?
Whenever we are asked to analyze data,
Some more example. Some more examples on uses of measures of central tendencies are as follows. In marketing, and how do we use measures of central tendency in marketing? So in marketing, marketers often calculate the mean revenue per advertisement. Marketers often calculate the mean revenue and per advertisement so they can understand how much money their company is making on each ad. In addition, they also calculate median revenue and per advertisement so they can understand how median ads performs. Finally, they calculate the mode of the type of ad used, e.g. newspaper, digital, so they can know which type of ad their company uses. Often. The next topic is measure of dispersion. So this one was tough. Fucking man. Tough. But I usually do this, but I don't understand it. Market, I use the mean revenue and per advertisement. In human resource manager often calculate the mean salary of individual in a certain field so that they can know what type of average salary offer to new employee. In addition, they often calculate the median salary in certain fields so they can be informed of what typically middle salary is for a particular field. Finally, human resource manager calculate more of different positions in the company so they can be aware of the most common position of an employee at the company. Real estate agent calculate the mean price of real estate agent calculate the mean price of houses in a particular area so they can be informed their client of what they expect to spend on a house. In addition, real estate agent also calculate the median of a house to gain better idea of a typical home price, since median is less influenced by outlier like multi-million-dollar homes compared to the mean. Finally, real estate agents also calculate the model of number of bedroom per house so they can be informed their clients on how many bedrooms they expect to have in a particular area.